In this lecture, we discuss about rectification of curves. So let us first take what is the history and origination of rectification of curves. The term rectification comes from the Latin word rectus, meaning straight. The problem of measuring the length of a curve, arc, it means arc length, has existed since ancient Greek mathematics. Archimedes in 2287 to 212 BC tried to find the lengths of spirals and parabolas. Later, during the 17th century, Isaac Newton and Gottfried Wilhelm Leibniz, the founders of calculus, developed formula for arc length using integration. The formal process of determining the exact approximate length of a curve using integral calculus is called rectification. Now, what is the meaning of rectification? Rectification of a curve refers to the process of determining the length of a curve between two points. In simple terms, rectification means calculating the total length of a curve, usually using calculus. Means suppose we have this is the curve. So if you want to find the length of this curve, so what is the starting point? What is the end point? So we want to use this, use the formula of rectification using integration, and we will try to calculate its length. It is particularly useful when the curve is not straight or easy to measure using basic geometry. What is the importance of rectification? It is essential in engineering designs for bridges, tunnels, roads, etc. It gives accurate measurement of material length, for example, wire or cable. It is also used in robotic arm path planning and CNC machines. Helps in estimating fuel uses in curved railway or road tracks. It is used in satellite path modeling and navigation system. It is also very important for fundamental of CAD/CAM software. Importance for pipe length calculation in mechanical and civil engineering. Required in 3D painting and animation for shape modeling. It is also crucial in aerodynamics, path estimation for aircraft design. It also helps in signal waveforms analysis in electronics. So so why we are studying about the rectification due to these reasons. Let us take some formula based on the rectification. The process of finding the length of the curve is called the rectification of the curve. So process of finding length of the curve. Since we know that there are three types of curves. So we will try to find out the different formula for all three types of curves. So let us first start from Cartesian curve. So let y is equal to fx be an equation of the Cartesian curve, then the length of the curve from the point A or x equal to A to B or from x equal to B is given by, for example, This is the curve. This is x-axis. This is y-axis. So let us try to find the length. This is the curve y is equal to fx. So for x equal to a to x equal to b, we want to find out the length of the curve from x equal to a to x equal to b, from this point to this point. So the formula is given by s is equal to integration under the limit x equal to a to x equal to b of root over 1 plus dy dx whole square with respect to x. This is the formula for rectification of Cartesian curve. Y is equal to fx. Here x is independent variable and y is dependent variable. Similarly, if the y is independent variable and x is dependent variable, then the equation or the formula for the rectification from y is equal to a to y is equal to b is given by s is equal to integration under the limit y equal to a to y equal to b of under root 1 plus dx dy whole square with respect to y. So only since we are using here x is independent and here y is independent. So that's why there is no major change in the formulas, only changes in the dependent and independent variables. Now the second equation is called parametric curve. So now how to find out the rectification of parametric curve? So let x is equal to f of t, y is equal to z of t, be equation of the parametric curve, then the length of the curve from point t is equal to a to t is equal to b is given by s is equal to integration under the limit t is equal to a to t is equal to b of root over dx dt whole square plus dy dt whole square with respect to t. So here parametric term is x and y are represented by only one variable t. Let us take the next formula for polar curve. Let r is equal to f of theta be an equation of the polar curve. Then the length of the curve from the point A from theta equal to theta 1 to B theta is equal to theta 2 is given by S is equal to integration under the limit theta 1 to theta 2 of root over r square plus dr d theta whole square with respect to theta. Now if the polar curve is theta is equal to f of r, then how to calculate the rectification of the that polar curve? So let theta is equal to f of r be an equation of the polar curve. Then the length of the curve from the point A r equal to r1 to B r equal to r2 is given by s is equal to integration under the limit r equal to r1 to r equal to r2 of root over 1 plus r square d theta dr whole square with respect to r. Similarly, if the polar curve is like that, r equal to f of alpha, theta is equal to g of alpha, means this is what it is, the parametric curve of polar curve. Be an equation of polar curve in parametric form, then the length of the curve from the point A is A from A equal to alpha equal to alpha 1 to B of alpha equal to alpha 2 is given by S is equal to integration under the limit alpha is equal to alpha 1 to alpha equal to alpha 2 of in root over dr d alpha whole square plus r square d theta d alpha whole square. So these are the different formulas to calculate the rectification of curve. Now, let us see what are the applications of rectifications. So, in civil engineering, calculating road and railway curves for accurate material estimation, we are using rectification. In mechanical engineering, designing gear teeth, profile and camshaft curves, electrical engineering, measuring the length of sinusoidal or wave-shaped signals are used with the help of rectification. In aerospace engineering, we apply rectification to determine the trajectory length of missile and aircraft. In robotics, rectification can use to planning the curves path of robot arms or wheels. In computer graphic, rectification measuring curved strokes in animation and 3D modeling. In biomedical engineering, measuring artery curves or bone profile in medical imaging can be obtained with the help of rectification. In automobile engineering, designing the curve of race tracks or suspension are can be can be calculated with the help of rectification. In marine engineering, estimating hull shapes or submarine paths, and in structural engineering, calculating the arc length of curved beams or arches. So these are some applications of rectification. In the next lecture, we discuss how to solve the problems or how to find the rectification of some special curves. Thank you.